a big set of gas distribution companies and also bought half ownership in a major gas pipeline. The connection to the Clean Power Plan is indirect. We don't think that gas, we expect that the Clean Power Plan, in order to comply with it, means less coal, more gas, and some non-emitting has to show up. And so, yeah, there'll be some more gas going through the pipeline, and that's fine. That's sort of a tangential thing. They aren't. Those gas assets aren't really part of compliance. They can't hurt if there's going to be more gas, but it was an investment for different purposes. I'm about out of time, I'm sure, but I'll let Eric cut me off. Go ahead, Don.
Just real quick. I forgot the question. New sources. You're regulating existing sources under the Clean Power Plan, Section 101B.
Yes.
And I'm always confused on new sources, new NGCC.
Yes.
Particularly, and how those are treated under REGS.
So in the mass-based approach, there are two flavors. One flavor in mass-based is existing units only under a mass cap. Another flavor is in each, and the EPA gave a target for that. EPA gave a slightly increased target if you include your new units in the cap also. So it would be new and existing in something called the new source complement. So there's a little additional set of allowances that if a state elects to include, a state can elect to include either existing only or existing and new with the new source complement. In the rate-based version, new units are not included. They're simply not part of the program.
Thank you.
You're welcome. They are under 111B. So all new units are subject to 111B, whether they're elected in or not, or whether the state is doing mass rate or whatever. All new units have to satisfy requirements under 111B, but not B.
Okay, I'm going to have to ask you to hold your other questions, but I'm sure Charles would take questions after the session.
Right. Good. That was fun. Thanks, everybody.
I'm going to trying to keep us on schedule. So our third speaker today is Erica Bowman. She's the chief economist at the American Petroleum Institute. And before you start wondering how one of those petroleum people snuck into this session, I want to remind everybody that they also deal with natural gas issues. In fact, prior to being with API, Erica was the VP of Research and Policy Analysis at America's Natural Gas Alliance. So I'm sure we'll hear a bit about natural gas here.
Thank you for having me. And so yeah, there's some interesting stuff that has come from the Clean Power Plan. And one of the things that at API, we started this at ANGA, and then ANGA and API combined. So now this project is housed at API. One of the things that happened, and I'll get into this, I'm not going to read, obviously, there's a lot of text on these slides. We will get to some charts that are more interesting to talk about. But when we originally kind of saw the proposed rule from the administration on the Clean Power Plan, there was a lot of talk about how natural gas can be helpful in helping to meet the compliance targets. And then a year later, or a little more than a year later, when the administration released the final Clean Power Plan, there was really no talk about natural gas as a compliance option and really focused on renewable energy and energy efficiency. Even though EPA and the transition from the proposed to the final rule cut out a block, one of their building blocks for the best systems of emission reduction standard, they took out that energy efficiency piece. They still made some assumptions and their own modeling of it, saying that people would implement a lot of energy efficiency. So what we did is we looked at what EPA did in their final report or their final regulation and looked at how they modeled the Clean Power Plan and what really was going on underneath in their assessment. So EPA uses the integrated planning model, which is a model that ICF International houses, and we use that same model to do our analysis. One of the things that we felt we had some credibility to talk about and change in terms of assumptions was the fact that we really thought that EPA was underestimating, the resource base for natural gas, which leads to higher prices. And so that was one thing that we really focused on. The other thing that we focused on is their aggressive assumption on energy efficiency. Now, as Christy was saying earlier, that energy load growth, electricity load growth is not robust these days. At the same time, I don't know that the efficiency targets that EPA assumed in their Clean Power Plan are also as attainable as EPA has talked about. So these are a couple things, and I'll go through them in a bit more detail. The other thing is we modeled the different compliance pathways. So as Charles had been talking about, there are different ways in which states can choose to comply with the Clean Power Plan. And so our modeling is really focusing on implementation, one of which is the national subcategory rates that Charles was talking about. The other is the state blended rates, and then you have mass on existing sources as well as mass on existing and new sources. So this is kind of how we broke it out. So we modeled two different reference cases, one of which is just replicating what EPA did in their business as usual case. That does not include a Clean Power Plant policy. And then we also modeled what we deemed our API CPP reference, or no CPP reference case. And that really is, we used a much more broader and robust natural gas resource, which leads to lower natural gas prices. And then from that different resource assumption, we then modeled the 4 different compliance pathways. And then from those, we modeled 3 what we called implementation choices that states had. So one of those is just choosing your compliance pathway, so choosing whatever target EPA set for you, whether it be a rate-based limit at the state level, or if it's a mass-based on a different, whether existing and new, and then allowing market forces to decide how to most efficiently comply with that standard. The second way was, instead of just allowing market forces to comply with whatever standards you select, you're forcing in that 1% year-over-year compounding energy efficiency target that EPA assumed in their analysis of the Clean Power Plan in their final version. And then the third implementation choice that we talked about is forcing in more renewables. So instead of just looking at what current RPSs are at the state level on the books, we took the, well, I'll go into this, but we basically took the building block 3 level that EPA assumed in the Clean Power Plan and forced that, had the states meet that as a kind of representation. So I just kind of went through that. We won't go through that again. One of the other things that we talk about, or how we present our results, and I think is important, especially when you compare them to other people's results and when they do their own analysis, is that we're really looking at system costs. So we're taking a look at the capital costs, the fuel costs, the variable operating and maintenance costs, as well as the fixed operating and maintenance costs, which is a little bit different than I think some people will focus on the wholesale electricity prices, as well as allowance prices. But when you look at the system cost, and I think if you're a state regulator, that's really the most important piece, because that's what's going to be impacting your ratepayers. Because sometimes when you look at wholesale electricity prices, especially once you make a capital investment, that capital investment doesn't always show up to the full extent that it should in the wholesale power price, because if I'm an operator and I'm bidding into a market and I've already made that capital investment, I'm still going to want to recover at least $1 in profit, even though it may not fully recover up to what my capital investment is. I still want to get that $1 versus 0 by not producing the power. So that's why we chose to do more of a system cost approach. The other thing is to kind of talk about a little bit why we think EPA underestimated the EPA or the natural gas resource is, well, one, you've seen where prices are today, and you've seen how robust production has been over the past several years. But there was a new study released earlier this year by IHS that said that we have over 1,400 TCF of natural gas available at less than $4. And of that 1,400 TCF, we have 800 available at less than 3. That is a significant amount of natural gas at really low prices that we can pull up and produce. And just for context, in 2015, we used 27.5 TCF of natural gas in total, not just in the electric sector, but both residential, commercial, industrial, and in export. And then this is a chart showing how basically where the EIA has been in their annual energy outlook versus where actuals have come in from a production standpoint and a consumption standpoint. So the AEO years are basically the time of when the production was done, or sorry, the projection was calculated, and then the projected year is showing, okay, this was the year at which that projection was made. And so you can see that not only has actual production exceeded the reference cases that EIA puts out, but it's also exceeded their high natural gas resource cases. So in our opinion, that kind of further shows how much production has grown over time and how much more efficient we've been as producers in pulling up the resource. So kind of going to, well, then what is our underlying assumption? Well, we used the 2015 Annual Energy Outlook High Resource Case. So we took the price-quantity relationship from that resource case, and we used that as an input as our supply curve for the IPM model. Because the IPM model has the ability to iterate, and if it sees a lot of natural gas demand from the electric sector, it can bump up prices a little bit, and you can see some feedback in between both consumption in the electric sector as well as in natural gas prices. Just for context, if you looked at what the EIA put out for their annual energy outlook for 2016, their high resource case from 2015 is actually in between their reference case and their high resource case for this year. So they're actually moving closer to where we have been saying that we think is more realistic. The other thing in our sensitivity analysis, when we looked at implementation choices, and we were doing more forced mandates, we used that 1% year-over-year load reduction to basically simulate what would be an aggressive energy efficiency mandate and the cost of that. And just to point out, so from 2004 to 2014, U.S. electric load growth grew by 5%. That's over the entire time period. But that also happened during a time when we had a lot of federal energy efficiency policies come online, as well as state energy efficiency policies. And we also had the Great Recession. And I think that's something that people should remember, that we still saw load growth over that time period. It doesn't mean that going forward we're going to have aggressive load growth. And in our assessment, I think we're using 0.7% growth year over year. So it's pretty mild, but it doesn't mean that it would lead to the load destruction that EPA is currently claiming, or as they modeled in their Clean Power Plan, where they're showing that load declined by 7.8% versus their business as usual case. And then in our renewable sensitivities, what we did was we took the building block 3 that EPA had in their best system of emission reduction calculation and said, well, this is the level that we're going to force states to hit as just kind of a point at which we chose. It wasn't necessarily tied to anything other than the fact that EPA had the data and we could use that as a point at which we could increase renewable mandates to achieve that. So the key findings of our results is, and I think probably the first one's the most interesting, is that when you use a much higher resource, and what we would think of as really the resource reality that we're currently in, you see that you get 30% emission reductions from 2005 levels. That's without any Clean Power Plan, and that's very similar to what EPA in their fact sheet for the final Clean Power Plan stated that the Clean Power Plan achieved. And they stated it achieved a 32% emission reduction by 2030 compared to 2005 levels. So it's very significant. The second is when you allow market forces in the implementation choice, not mandates, to solve for your emission reductions, you see that total production costs are lowest. And then when you look in that why those are lowest, it's often because you're using natural gas as the solution to which you're getting those cheap emission reductions. So the other thing that we found as we ran all these different cases, and this is a little bit in contrast to what Charles was saying, and certainly this is at a national level, and state by state may be different, but we found the most stringent policy to be the national rate-based plan. So at the facility level, you have the subcategory rates, and we found that you needed 840 million tons of reductions to meet that across the United States. The next most stringent was using the state rate-based approach. And then the third most stringent was then going to mass on both existing and new sources. And then the least stringent application of a compliance pathway was looking at mass on existing sources only. And what we found was that we were actually able to meet the emission reduction targets just by having a more economical fuel choice that we believe is more representative of reality than what EPA had in their modeling. And so you achieved as many emission reductions as needed just by choosing a more affordable fuel than what the Clean Power Plan target would have you meet. And then on the generation side, on the capacity side, the upper right-hand corner chart is showing capacity change in the API reference case without the Clean Power Plan, just to show that things are going on independent of the CPP. You have a lot of coal retirements, you have a lot of new natural gas combined cycles being built. You also have solar and wind being built, mainly, at least in our modeling, that's due to renewable mandates at the state level. And then you have these different charts. So one of the things that kind of what we decided as we were figuring out how to present this stuff, because it does get a lot of data and complicated, is that we really felt like we needed to stick within each compliance pathway because the stringency was so different between them that it didn't make sense to compare them to each other. So that's why you have, we put up a rate base, so that's the blended rate base approach, and then you have mass-based limit on existing and mass-based limit on existing and new sources. And so you can see that in the market forces cases, you have more natural gas combined cycle capacity being added. And then when you start forcing in energy efficiency and renewable mandates, that declines. The new natural gas combined cycle capacity declines relative to the reference case. And then you get, whether it's energy efficiency, you get less load, or if it's increased renewables, you get higher renewable builds. And again, this is looking at generation across the different cases. And you can see in the market forces cases, you get the most natural gas generation because it's natural gas that's really providing the affordable emission reductions. And the last slide is looking at the system cost. So how does this generation mix and capacity mix change and impact total cost for the systems? And what we see is that in the market forces case, you get very little cost because you're utilizing existing natural gas facilities as well as also building new natural gas facilities that would already be built in the reference case. In the mandated cases, whether it be energy efficiency or renewables, you see that it's much more costly, relatively speaking. And the biggest reason for that is the capital cost that you're putting in to either get the energy efficiency reductions or the renewable capacity that you're adding is much higher than the fuel savings that you would see on the back end. So you can see how each component, from a cost component standpoint, how each of those are changing. So for instance, in the state rate base limit on the green, different green chunks of the bar, those are your fuel savings. So you are getting fuel savings when you add increased energy efficiency and increased renewables. It's not enough to offset your capital costs. And then the black line is really the net change between all those bars. And that's all I have. I'm happy to take your questions. What's that?
So we can make about 1 and 2.
Questions?
Sure.
For the existing source standard, do you have any leakage provisions?
So we did, but we modeled it both ways. We modeled it with leakage and without leakage, and what we found was it didn't change the results at all. And we thought that was pretty interesting. In fact, when we looked at the rate-based version of the state blended rates, we actually saw what EPA defines as leakage happen more, where you're transitioning more generation to new combined cycles and not utilizing your existing sources, which was counterintuitive to us, but that is exactly what was going on. Now EPA says that leakage isn't required for the rate base because, well, that is the standard itself, and that's actually how EPA should, from a legal perspective, they need to regulate because it is a rate-based requirement. Yes?
Just to clarify something for me, the idea of using natural gas as fuel switching, what it was originally, the whole concept is no longer going to be part of it. It's not something.
No.
Projections that would be the case if it was allowed, but it's not going to be allowed.
No, it is allowed. It is part of the standard in how, so the way EPA created their standard is they use different building blocks, one of which was switching from coal to natural gas. No, the rhetoric, sorry, apologies, the rhetoric that EPA was talking about when they released the final plan, they didn't talk about a lot of increased use of natural gas. But it was really based on their assumptions that they put in their own modeling of what they call their regulatory impact assessment, their RIA. And because they assumed a much higher natural gas price, as well as increased energy efficiency, you didn't see the same kind of natural gas utilization that you see in our results when we think we're using a much more credible natural gas resource, which leads to a more credible price. Yes?
The thing that sounded very surprising to me was that you had the energy efficiency much more costly than the increased resource supply. So how did you model energy efficiency that brought you to that?
Yeah, that's a great question. So the way we actually took, when we did the energy efficiency implementation choices, we basically took it off the top, so we reduced load by that amount, the same way in which EPA did it, and then we assigned the same capital costs that EPA assumed to that volume of energy efficiency. So the model is not solving for energy efficiency. We didn't give it a supply curve for energy efficiency, mainly because when you do supply curves of energy efficiency, oftentimes what happens is that the model will select that as at least, but we took it off the top, so it wasn't the model solving. But the issue is that because the difference in our modeling to what others are modeling is the fact that we're having such a higher resource, which leads to a much lower fuel price, which is then making the energy efficiency capital cost not as cost competitive.
So is it fair to say that it wasn't a conclusion of the model the energy efficiency would be more costly way? It was basically an assumption that you built into it.
Right, if you price the natural gas at a more rational rate, then it'll dispatch. I mean, that's basically how EPA helped put the model. If you assume the natural gas is expensive, you'll use less of it.
Yeah.
I'm not talking about the natural gas, I'm talking about the energy.
So I would say it's twofold. I would say it was definitely an assumption in terms of the level of energy efficiency, but the fuel savings that you get from the model from that reduced load is a modeled output, and you're not getting enough fuel savings to offset the capital costs that you would get for that energy efficiency. Yeah.
I have a question for the fire company. This is on assuming that clean power plant goes forward, and now it's up to the states, which is for to choose. Who does the state turn for to get information? And also, who begins counting the states? So, for example, Southern Company, are you interested in influencing states as to guiding states, or what are the groups that would try to guide states in one direction or another?
Well, I mean, we are meeting with states as API and talking about these modeling results because we think it's important for them to at least consider the fact that, at least in our belief, that natural gas resource is much more abundant than a lot of other models show, or at least assumptions show. But there's a lot of people meeting with the states, including the NGOs and other utilities, et cetera, that are talking about their own results, as well as if you're in an ISO or an RTO, they're meeting as well. So there's a lot of stakeholders, and it just kind of, I guess, depends on what your message is.
Yeah, excuse me, yeah, I'd agree. The conversations are when it comes to a state trying to make a decision about whether to do a rate-based approach or a mass-based approach or whatever they want to do, I think that most states are likely to have a really robust engagement on that. It's an excellent question as to where the analysis that the state decision makers are going to rely on is going to come from. We've been encouraging consulting firms that have a good handle on doing this kind of analysis and others to be at the ready for states to go ask them, hey, help us decide, or do some analysis to help us decide. Issues have been raised in the multi-stakeholder process. How should we decide? So, at least for our states, there's a spectrum of who's convening those and how aggressively they're being convened and how many parties are invited and who all's involved. But I think both in our states and around the country, there are organizations that are trying to put together those conversations even now during the stay.
Part of it's going to be when you're talking about your solutions that, how you're weighting your outcomes. There's some states that are very, very focused on, how maximizing their emissions reductions in a trading environment, and then you have others who are looking for, a more cost-effective solution to still get you to the same compliance point. So, among states, there's a difference in the weighting. There's states with a 50% renewable portfolio standard. So if, New York achieves it, the likelihood of them having a compliance issue is probably pretty low. So at that point, the question is how do they figure out how to get involved in a system that helps them monetize their surplus so that they get something back for their investments? And so there's a lot of layers for the state decision makers that are, so you can come with, a great gas model and says, look, the most cost-effective way for you to do this is to use gas, and say, well, we've got it, we're reforming the energy vision and we have an entirely different objective. And so part of it is not just the numbers, part of it is the policy priorities that each state is selecting based on who's in charge at the time and that obligation, those decisions get made.
Yeah, the analysis is one part of it.
I guess I wanted to go back to that energy efficiency thing. So I'm kind of, can you clarify, because I know from IPM thinks like electricity generation as exogenous. So I guess by tweaking the energy efficiency component, the EPA runs versus your runs are generating different numbers, right?
So
putting in different electricity generation number like forecast.
So on the demand side.
So you're basically tweaking two sides of the.
Well, so
you
EPA.
try like using EPA's generation number and then seeing if your new.
But so when it's a demand, so it'd be the load. So so you get the result of the IPM is so one of the constraints would be that you would have to have generation meet your load. And so it's the load assumption that is an assumption that you're putting into the model, which is exogenous to IPM. So EPA, when they modeled their clean power plant, as an assumption, they took off the top 1% year-over-year compounding load reduction due to energy, contributing that to energy efficiency. We did the exact same thing when we said we were forcing in mandated energy efficiency. We didn't say that the model solved that. We were forcing that in by taking load off the top, basically taking off the top as an input. The model solves to meet that. And what happens is that you have to assign a certain capital cost to that energy efficiency assumption, which we used EPA's capital costs. The reduced fuel, basically reduced generation, which results in reduced fuel, wasn't enough in our modeling to offset the capital cost that EPA also used, because we had lower fuel prices. We had lower natural gas prices, where EPA had higher ones, and so they saw a net savings there.
Okay.
Let's see, we have time for a few more questions for any of the panelists, and then after that, we'll call it. Questions. I'm sure a few of you will probably come up here and chat, and you're welcome to do that. But I guess let's thank our panelists. everybody that there's a reception a couple blocks away. They mentioned it at lunch at 6:30, and I think they want to remind everybody to take your little tag and your drink tickets. Those are both mission critical items. Yeah, thank you.